Thank you everyone for joining us for another tutorial. In this session, we are going to learn about classes, structs, and interfaces. As we move forward and deeper into the C# language, our courses will be more complex and more extended, but we will do our best to keep the subjects as clear and concise as we can to help you build a solid foundation in C# programming. So please note that this session is intended for beginner to intermediate. That said, we will go over the essentials and forego the advanced materials. When we reach our advanced playlist, we will revisit the subjects and go over areas not covered. So before we venture into our subject, let's take a few moments to go over namespaces. Namespaces organize your code or libraries. We have hinted at libraries like .NET base class libraries, and more on that later. Another way of looking at this in the real world is if we ask you what area you live in, and you might name the country, state, or city. Now, if we try to translate this to namespace and you lived in the US, here is what that would look like. USA.California.Beverly Hills. This would be our namespace. Let's look at how Microsoft has organized its namespaces by reviewing the classes we have used. The console class resides in the system because it's a system function. File class resides in system as well, but is further defined in the I/O, input, output, and delimited by a period. If we look at the base class libraries, console and file, we can see that they are structured in their own libraries, but have shared namespace structure. Note that the class string resides in a different base class library, also shares the system namespace. Now let's review the namespace usage. Our C# template project has a namespace with the same name as the project. If we look at the project properties, you will notice that it's been defined as a default. If you wanted a different namespace, you could change it. Whatever name is used in the project settings is applied when you create a new class, struct, or interface. We can also change this after the creation of the source code file. If the using keyword is applied to declare a namespace, it precludes the requirement to specify the name of the namespace for every class. If we didn't use the declaration, then we would have to explicitly write system.console.writeline hello world. There is also a root level global namespace and can be used with the following syntax: global : system.console.writeline hello world. It's extremely rare to see the global namespace, but we wanted to point it out. Generally, you would see the global namespace in automated code generation. In C#, each source file is a compilation unit, which defines the structure of your source code files. When you build, compile your application, all your source code compilation units are processed together. So let's understand namespaces further by creating our own. We will create two classes, student and instructor. Since our classes are created in the same namespace, we can use them. Let's rename the namespace for the student. If we try to use the student class in the program's main method, we get an error. That's because we either need to explicitly add the namespace before the class or employ the using directive. Now, let's remove the namespace so that it will reside in the global namespace. You can see that we can find the student class. That's because as its scope is in the global namespace and is available without explicitly defining the global namespace. Please note that we have now 3 compilation units in our project: program.cs, student.cs, and instructor.cs. Declaring the namespace with the using keyword can be before or after the namespace. We can also nest namespaces. If you nest namespaces, it's equivalent to the following by using the period. Note that you cannot have the same code file name, but you can have the same class name but in different namespaces. Sometimes the namespace might be too long, or classes named the same will have conflicts. In this scenario, you can alias the namespace. The alias can be applied to a type as well. There are also other features that are not widely used, and we will skip it. We will, however, provide a link to the C# language specification for namespaces for you to review, and additional topics not discussed in this tutorial. Now it's time we moved on to our main feature. Classes, structs, and interfaces hold the structure of your data, but they can do more, as we have seen in the file and console class do. They can perform actions. We know a little bit about structs, so let's start there. Struct type has value semantics. What this means is that the structure is copied by default when assigning, passing an argument to a method, and having the method return the result. This is due to the struct type being a value type. As a best practice, you should use structs for smaller data types that will have little behavior. We have created structs, but didn't go over the details. The simple anatomy of a struct is the name of the struct and open closing curly braces. Inside the curly braces is the struct scope, where you would add your own types, for example, int, double, and or boolean, or any other type, including your own. Structs start with an access modifier. The access modifier sets the rules of objects that interact with the struct. Next, we have the struct keyword, identifying that it's a value type. Then we have the struct interface. This is something we will go over when we discuss interfaces. Finally, we have the struct scope, where we can create members to hold our data. So now let's review each section in detail. Access modifiers help the interaction of code form outside and inside. Here are the 2 that we will discuss, but there are more modifiers. Public allows any code inside or outside your library to interact with the struct. Internal, only accessible inside its library. So let's see this in practice, and we will start with public. Before we continue, let's explain libraries and how to create your own. We have gone over a console app, and we said that it was an executable. All right, a quick detour. XE is a Windows term, but .NET Core is cross-platform, so an XE means something different in other operating systems. Other systems do have executables that launch applications, but they do not understand Windows XE. When you build a .NET Core, in our example, C# template, you get C# template XE and C# template DLL. C# template.xe can only execute on Windows, but C# template.dll can run on other supported platforms. If we launch our console app XE from the command prompt, we get the expected response. The application launches and executes our code. Notice that we have a DLL with the same name. If we try to execute it, then we get an error. If we launch the DLL with .NET command, then we get the expected result. So .NET file name .dll command can be run on any supported platform to start the executable process, provided that .NET Core is installed. When we discuss publishing of your application at a later tutorial, you will find that you can package .NET Core with your application and it will not require a .NET Core installation on the target server. The big difference between DLL and an executable is that an executable is hosted in its own process space, and DLLs can be consumed by the executable or other DLLs. To break it down further, an XE is used to launch an application and has its entry method that starts with the code execution. So in the example of our console apps, we always had the main method as the entry into our applications. A DLL provides methods, classes, etc. to be used by an application or other DLLs. You can identify the executable versus DLL by looking at the file header value. Okay, now let's get back to our example of access modifiers. We need to create a DLL and place our structs in it. Like we did with the console application, we will select the default template for a DLL. Now we are ready to create our struct. In order to use our DLL, we need to reference it. Referencing is a way to link your project to other projects or DLLs, even other .NET executables. When you reference a DLL, what you're doing is that once you built your solution, Visual Studio has a build order and knows that the DLL needs to be constructed first, so it'll generate a DLL, then build your console with reference to the compiled DLL. So hopefully this gave you guys a quick introduction to applications and libraries. Now that we have a public modifier, it's accessible to our C# template. If we make it internal, then we get an error, but we can use it in our class library, not outside. So our struct for now does nothing. Let's add some structure to it. To do that, we need to create members. There are many members, but for this session, let's just keep it to 3: field, method, and property. A field is just a variable of any type in our struct. A property is a member that allows an easy way to write and read fields, can also have additional logic. A method, as we've seen, contains a series of actions that we can perform. All of the members mentioned also have access modifiers, and we will discuss only 2 of them for now, private and public. So same as before, the public allows external access and private only to the struct. Let's create our struct for US-based phone numbers and use the members we just discussed. We are going to emulate US-based phone numbers. The US phone numbers are in 10 digits. The first 3 represent an area code. The next 3 represent exchange. and the last 4 is a line number. We need these numbers to be in 3 distinct patterns so that when we pull it together, we can get a phone number format. So we can start out with 3 fields that are used inside 3 properties and 1 method that prints out the phone number format. The properties and fields are going to be ints. The method is going to return a string but accepts no parameters. This is a good example of a lightweight object that maps to a struct. This struct in the real world has a lot of problems. For example, the US phone line number can start with 0. So we pass a 0123, then the int will be 123. What if the user chose to only send 2 digits for area code? In later tutorials, when we have learned the essentials of C#, we will build real-world applications to address issues like that. Now that we have a structure, how do we instantiate it? In previous sessions, we used the new keyword to construct a class. For structs, you don't have to do that. There is another way. If you don't use the new keyword, then you must initialize all fields. If the fields are private, then you must use the new keyword. In the print phone number method, we use string interpolation. You have also seen us use it. We will provide a link to the description of the tutorial, but we will review it in later tutorials. In short, string interpolation allows us to merge our variables with our string. Now let's review our properties. When we created our properties, we had a get and a set. They do exactly as it's noted. It allows code to interact with it by setting and getting values. Our properties are doing much at all right now. We can add some rules in the setter or getter to help enforce that we are setting values correctly. We will modify our area code so that it allows only 3-digit integer values. As a best practice, keep the code in either setter or getter short and quick. If you don't have code that needs to be complex, then it's a good candidate for a method. So let's put some more rules for our other properties. One more note, in the property setter, we use a keyword value. Earlier, we stated that we could not use the C# keywords. This is because C# has what's known as contextual keywords, and they provide specific meaning in the code but are not reserved. Value is a contextual keyword, and therefore we were allowed to use it in our rule length method. In our struct value was used to set the accessor in our properties. Value is similar to a parameter in a method. You probably ask yourself why the fields? Why not just take them out and use the properties as they are? Well, that would work. There are scenarios where you don't want to have anyone modify your structs property, like when we saw the string length. We could get the value, but we were not allowed to update it. So having fields can help us use it internally, but enable the property to expose the endpoint for other code to consume. This is just one using of fields. We can also use fields as variables in different methods. We have already seen methods in action, but we should do a quick review. Methods, just like the other members, have access modifiers. For now, we will keep it simple to private and public. Methods can return values of any type and accept 0 or more parameters. This brings us to another aspect of the struct. Notice that when we newed a phone number struct, we added open and close parentheses.
When newing a struct, you are actually calling a constructor. By default, a .NET created a constructor when the code was compiled. Every structure type has an implicit parameterless constructor. So, what is a constructor? A constructor must have the same name as the type, and it's a special method that we can initialize members of your type.
We are now going to make our phone number struct allow its properties to getter only and initialize our fields via a constructor. When we created our role to check the length of a phone number value, we left else empty. So if a calling code did not enter a valid value, how do we notify the caller that they are misusing the struct? We can raise an error. In .NET, we call them exceptions. Exceptions are a topic that we will review in depth, but we wanted to give you a quick intro for now. To raise an exception, we would use the keyword throw. The exception is a class type. We would instantiate it and populate its constructor just like we did with our struct. So now, if the caller tries to use our struct, they will get an error and the program halts. We will go over how to handle these types of scenarios in later tutorials. So when should you use fields, properties, and methods? Generally, you should use fields for a variable in your structure class, meaning it's private and only your object can access it. Fields also allow it to be accessible by other methods and properties in your object. So fields will enable the data type to be shared across the scope or body of struct or class. Properties are like fields, but have a method-like function. Avoid complex logic in properties. If the property already has a value, but then it's being set and it throws an exception to preserve the previous value, avoid throwing an exception from the property getter. For methods, keep the complex code there. That doesn't mean that you should add hundreds of lines of code in your method. Break the method into categories. Each category should have its own method. Another way of thinking about it is not to have more than 4 logic statements in your method. This is to keep your code clean and readable. Once we discuss solid principles, this will make more sense. This should be a good review for structs. Let's review interfaces. We are going to give you an introduction as interfaces play a big part in object-oriented programming and solid principles. This is the advanced section of our tutorial and we will review it after this playlist is completed. Interfaces define a contract. Interfaces can contain members, but we will discuss only 2 methods and properties. There is no implementation for interfaces. For example, a method will not have a body. Interfaces define the contract that a class or struct must implement. Let's take our struct for phone numbers and make it adhere to an interface contract. We want the properties and methods to be a part of the interface. Now, how do we use it? Our struct can inherit the interface by placing the interface name in front of our struct and before the body. We can also create a new phone number struct that inherits from our interface but has an additional structure like country code. Let's move on to classes. Everything you have learned so far about struct can be applied to classes. As a matter of fact, all we have to do to convert our struct to a class and keep all the features is to replace struct with class. Now, there are differences between the two besides struct being a value type and class being a reference type. Another thing is that structs can only inherit interfaces, whereas classes can inherit other classes. Both classes and structs can inherit from multiple interfaces, but a class can only inherit from one other class. Classes can also mix between class and interface inheritance. For now, here's our advice. If you have short-lived objects, make them structs. If you have objects that contain other value types or immutable values, keep them as structs. If the object includes complex functions, make them classes. This should be good for a beginner, but don't worry about performance just yet. Now that we have a better understanding of value types and reference types, let's review one more time passing of values visually. In the following example, we have three variables, an int, a string, and a class. First, we are going to pass it by value to a method, then update them. Note the visual as we update the three variables. For int, we copied the actual value to our parameter. This parameter has a different scope, so updating its value will only update our parameter in the method scope. The update to the string is a little bit different. The string is a class but acts like a value type. As we update the string, we create a new string on the heap and update the pointer of the parameter in a method, and it should not have any effect on the variable in our main. Remember, since the string is immutable, we just allocate a new string. For the class, as we update its property value, we are not updating the reference, but the value of the property. So, after we leave the method, it should reflect the updated value as we acted on the copied reference. Now in the next method, we are doing the same thing, pass by value, except we are now newing a class. What do you think should happen? Do we update the variable in our main method? The answer is no. The reason we are not updating the class variable in our main method is because we are working with by value, which means the scope of the parameter is being updated. If it were passed as by reference, then we would be updating the class in our main method as the parameter would have our main method variable scope. Please note, when we created a class, its members that are value types are created on the heap with the class. We hope this has cleared any confusion on how the value type, reference type, and string works when passing. There is one other important topic about classes. They inherit from a root level object. So for example, if we were to decompile and look at the string class notice, it's inheriting from an object. .NET language does not require explicit inheritance from an object because it's implied. Which brings us to another topic, boxing and unboxing. So boxing is the process of converting value types to the type object, a reference type. When a .NET boxes a value type to an object, it is stored in the heap. Remember, the object is a reference type. We wrap the value into the object. Unboxing reverses the process, and we store the object's value back to the stack and in the value type. So why does .NET have an object type? There are scenarios, especially when connecting to databases where we do not know what type we are dealing with. So we get back to an object. Another example is the arrays that we have been using are a collection of objects. The fact that we can treat any type as an object underlines C# unified of the type system. Boxing and unboxing is a typical question that is asked in interviews. So don't remember the definition, but understand how .NET works under the hood. This will be important when we discuss performance. So for now, we are not going to worry about that. Let's inherit good habits to write good, clean code. We are now ready to see a real-world example of using classes, structs, and interfaces. In this example, we are consulting with the super duper university, and we are tasked to allow instructors to view their classes and take a roll call of the students in their classes. The instructor can also view student grades. We will read the data from files as we have before, but this time we are going to create an in-memory data structure to work with. In the real world, we would be accessing the data from a database, but since we don't have that skill just yet, let's emulate one. After interviewing the super duper university team here, what are the requirements? The system should log the instructor into the system using their name and ID, then show only classes an instructor teaches. Once a class is selected, the instructor will have the option to view student grades or take roll call. The instructor can also search for classes, so we need to have that option as well. And so now, we look at the requirement and go over the core functionality as this will be our success criteria. So number 1, we need instructors to log into the system. This is a must-have. Number 2, we need to view classes and search. Also must-have. Number 3, we need to take roll call. This is a nice-to-have. Instructors can take attendance using pen and paper if this requirement is not met due to time constraints. Number 4, select a student and view their grades. This is also nice to have. Again, instructors can have the information on file. At this stage, we would get approval from the client that we have accurately captured the requirements, and once we get consent, we then move on to the next step. Our core feature of the Super Duper University application is the first 2 requirements. Next, we need to approve the screen designs. We have used PowerPoint to mock up wireframes based on the requirements, and we will share the PowerPoint mock-up screens on our code repository site. This will get approval from the client, and we will move forward to the next stage, designing our application. We have created a diagram to help visualize the process. So where do you think we should start? We will begin with the wireframe mockups and work our way down to access the data. We need a class to manage and keep track of the screens we are on. We will call this class Screen Manager. The Screen Manager will also have an array screens, which are also classes. Each screen is responsible for handling user interaction. So how do the screens get data from our in-memory data structure? We will pass a data interface that will process the data calls. Students and instructors and other data from our in-memory data structure will be presented by Structs. We have already provided you with a set of guidelines on when to use interfaces, classes, and structs. As we create the application and implement the features, it should paint a more clearer picture of when to choose which type. And remember to spend as much time as you can in thinking and how to approach your applications before writing a single line of code. All right, well, time for the fun part.
Before we continue, here's a disclosure. Please remember that at this stage our knowledge is limited, so this application is far from complete or correct. This exercise is merely building on what we just learned, interfaces, classes, and structs, we will link to the source code, and at some point, we will circle back to fix most of the issues as we gain more skills. Also, we are going to build the application up to must-have requirements, login, and class display. We will leave the rest as a challenge for you to build on. We will start by creating a new console application and name it Super Duper University. The project name will also serve as our namespace. We will start with a skeleton application and building on the home and login screen. Once we have successfully implemented, we will do the rest. So let's start with Screen Manager class, and this will be our entry to our application. Next, we will create the home and login classes. We are going to organize our code and add a folder called Screens and add our current related classes. Then bring our CSV files. We'll create another folder called Data and add the related CSVs. Next, we'll create a data access folder where we will have our emulator to read the CSV files and provide access to the data. Let's quickly fix the namespaces for our screen classes. The Screen Manager class is responsible for building on the forms, and the screen, like home and login, is responsible for displaying and handling user interaction as well as moving to the next screen. In the constructor of our Screen Manager, we will add some logic to initialize the screens. Going over the home and login, you will notice that we have a pattern. We need to be able to move to the next and previous screen, as well as display and handle user commands when the screen is displayed to the console. We can create an interface that holds that contract for us. Next, our classes will inherit this interface and implement our contract. So if we want to build other screens, they must inherit from the iScreen interface. Since the screens are responsible for going forward and backward to different screens, we need two properties, next and previous. Let's work with the home screen and map it to our mockup. Let's also add some logic to move us to the next screen. If the user does not enter a login, then we display the screen with an error message. To do this, we are going to call the method that we are in process commands, also have our logic, that is a message is passed, meaning it is not null or empty, and then we display that to the user. If the user entered login and we are matching it to lowercase, then we need to move to the next screen. In our case, the login screen. For now, let's just add something on the login screen so that moving to the next screen works. Next, we'll set up our screens and test the application by calling the process commands of our starting screen. Oops, we have a little bug. Let's make sure that we are matching the word login. Now we are going to test the login message on the home screen. It works, but we need to clear the screen first. The console class also allows us to manage the command console window. So let's add a title to stylize the application. Now we are ready for the data access class and load our instructors so that we can handle the login screen. But instructors and students are the same person.csv file. So we need to load this file and keep the results in memory. Our data access will need to initialize our data so that we have two constructors. The first constructor will accept no parameter and expects the CSV files to be in the same directory as the application. The next constructor will have a path to the CSV files. To load our data, we need some kind of structure, one for student and one for instructor. Most of the columns are the same, so let's use an interface that both instructor and student can inherit. The columns that don't match, like the hire date and enrollment date, will be properties of their respective structure. Let's create an interface called iPerson. Anytime you create an interface, it's a good practice to start with a capital I, then the name of the interface. Our interface name is iPerson, and we'll have the following properties: person ID, last name, first name, discriminator. Now we're ready for the two structs, student and instructor, that will inherit our iPerson interface. Next, we add the columns that are not shared with each struct. Reading CSV files should be familiar to you, as we have used the technique in our previous string ATL application. Now let's make sure that our files are copied when we build the application. Please note that if a file exists in a folder and we mark it to copy, then the folder will be created and the files will move inside it. Now we can loop through all lines and load them into student or instructor struct. Making sure that we ignore the first row, as this is the header, so our loop will start from 1 and not 0. Let's create two methods, each responsible for mapping our structs. Arrays need to have a size, and since we don't know this at this time, we initialize it with 0, empty arrays. So to add to the array, we need to resize the array by 1 and then add our object into the array. This is not correct and not the most efficient way. So when we learn of iterator and loop in our next tutorials, we will fix it correctly. Let's map the objects and create public properties that can be used once the CSV files are loaded. We are going to use private fields and public properties, but with only a getter, so that it's protected and cannot be changed. Now that we have our data access emulator, let's create it and run a quick test so that we can load the CSV files. Seems like there's a small bug where we don't need the leading backslashes. So let's fix that and try it again. Another small bug, we are selecting the wrong column. So once again, and now everything looks good. Next, we need to authenticate instructors on the login screen. So to do this, we need a class that is responsible for validating instructors. Each class should be responsible for doing one thing. This will keep your code organized, reduce complexity, and easier to fix bugs or introduce new features. So let's pass the data access to the screen manager, as our login screen will need to have access to the data. We need a class that will be responsible for authenticating the instructors. So let's create a folder that will hold our business logic. Then, using the data access, we can create a new method to authenticate instructors. The method will check both user ID and name. If there is a match, you're logged in, else fail, and not allow the user to proceed. It looks like we don't need data access to be passed to the screen manager, only the authentication class. So let's fix that. We also need to pass it to our login screen, since the authentication login needs to be there. Then we need to make sure that the user has entered some data for us to use, then call our authentication method. If the username and user ID exist, we move on to the next screen, else we display the error to the user and allow them to try again. a quick test, and we can confirm that the login screen works correctly and we can handle errors. We can now start on the instructor screen, where we will display a list of options that the instructor can act. As before, let's add our instructor screen and inherit from the I screen and add the implementation details. We have 4 options. Let's add the checks after the user selects a valid entry. We also need to add methods that will show additional details after the instructor selects a valid option. We are now ready to register our new screen in the Screen Manager class. Then we need to have a new class that will handle the logic of the instructor selections, like display all courses for that instructor or gets the details of a selected course. Let's add a new university catalog class in our business logic folder and wire up the data access to it for extracting the class information. Since our instructor class will need this object, we need to construct it like we did the authentication class and pass it along to the Screen Manager. Now we're ready to consume it in our instructor class. We need a method to get a list of classes that belong to the current logged in instructor and will pass back an array of courses, which means that we need a new struct. We also need to remember our instructor ID once we logged into the system. So let's create a new property. Let's get the data from the CSV file for the courses. And as before, we will add a new public method that returns a list of all university courses. We are also going to need the CSV file that maps our courses to our instructors. So let's add a new method for that. Now we'll create our struct for both, and then the same logic as before to mapping them. Now that we have the data, let's get back to our catalog object. We need two loops. The first loop is responsible for extracting the courses that the instructor teaches. Then the second loop only gets the courses if the instructors are assigned to it. Let's fix that instructor ID so that it's part of this iScreen. Now all screens have them for us to use. After login to the system, we will remember the value before moving to the next screen. Let's test the application, and looks like we forgot to wire up the Screen Manager constructor in the program class. We also have some copy and paste issues that we need to fix. Now that the screens work, let's add the logic to display the courses. We will also copy and paste the display information and add an option. If the option is valid, we can then move to the next screen, and if not, stay in the same method with a message to the user. We also need to remember the class if we move to the next screen so that we can display its details. If we look at our mockups, you will notice that we need to greet the instructor by name. So as before, let's add another property. Everything works, except for we don't have the next screen for the course details. At this point, adding a screen should be simple. Let's just watch without narrating the details. We will leave the rest of the nice to have requirements for you as a challenge. So thank you again for joining us for another tutorial. And in our next session, we'll go over iteration and jump statements, recursion, indexers, and generics.